Division of Agriculture soil scientist Rick Norman and his graduate students had developed the first and only field-specific test of soil nitrogen as a basis for nitrogen fertilizer recommendations in any crop. It's called Nstar for Nitrogen Soil Test for Rice. Verification tests in fields of cooperating farmers will be conducted in 2010. This new technology is expected to greatly increase the efficiency of nitrogen fertilization. It will help producers optimize rice yields and reduce the potential for nitrogen in runoff from fields. The Arkansas Rice Research and Promotion Board and USA Rice Federation helped fund research for its development.
Now what I want to talk to you about is nitrogen soil tests we've been trying to develop. Scientists have searched one for decades. So many have been proposed, but none have been able to develop a decent calibration curve. We think we got one. We still need to do quite a bit more testing, find out when the best sample time is. Can we sample in the fall? Do we have to sample in the spring? But Trent Roberts, a student of ours, has done an excellent job in the development of this method, and I'm going to let him tell you about where we're at right now. Trent?
In the past few years, I've had the opportunity to work a lot with this soil test, and it's some pretty exciting stuff in terms of rice production, the long-term sustainability of U.S. rice production, and just in general, potential savings for producers across the state. Essentially what we've looked at is a way that we can predict nitrogen fertilizer needs on a site-specific or a field-specific basis. And essentially everyone is familiar with the current recommendations that we use, and they're generally based on the variety and the soil type, texture, and the previous crop that you have been growing in a field. How often do you grow a variety and you see the recommendation is 150 units of N per acre? That's just kind of traditionally what has been done in the state, and I'm sure all of you have noticed areas where maybe your native fertility is a little higher or your native fertility is a little lower. And those are just kind of some natural things that occur. And up until now, we haven't been able to predict when those types of things are going to happen. And through the development of this soil test, we feel that we're in a position now to where we can go to a field, pull a soil test, and give you an accurate prediction of your nitrogen needs for a rice crop within that field. And as you can see here, this is just an example of our calibration curve for silt loam soils. What we have is a wide range of producer and experiment station fields here, which we've used to develop this. We have sites essentially where no nitrogen was required to produce a maximal yield, and then you have other sites that required more than the standard recommendation to produce a maximal yield. So there's a wide range of variability out there, which is something that we do have to deal with. One thing that we've tried to do is every producer is different in terms of how they approach a situation, in terms of their fertility, their management, and their input costs. One thing that we've tried to do in developing this recommendation is give producers a choice of how they want to manage this new soil test. What we've done is created 3 different calibration curves. One that will result in 90% relative grain yield, 95% relative grain yield, and 100% relative grain yield. If you want to talk in terms of statistics, generally 95% relative grain yield is never different than 100%. There might be a numerical difference, but there's no statistical difference there. But what this does is this allows a producer, based on either nitrogen fertilizer costs or his general input structure of how he wants to deal with the field, he can choose to use any 3 of these calibration curves. So if you're a pretty conservative type approach, you might want to use the 100% curve to predict your N rate. But if you want to pull back, if nitrogen fertilizer prices are starting to increase and you feel that you can pull back to a lower N rate, you might want to go with the 90% curve. And most often, what we find is the 90% curve is going to get you very close to maximal yield in a field. One thing we will point out is that if you're going to push the envelope and you want to try to use this 90% curve or even the 95 curve, the major assumption that you have to deal with this particular soil test is that all your other nutrients are optimum. Essentially your water management, your nutrients, your other inputs are optimal in order to achieve that maximum yield. So, this means you're going to have to monitor that P and K closely. You're going to have to monitor those other inputs when you try to use this 90% curve. One thing I would like to show you, currently we're in the process of what we call validation. And so essentially this is where we go out and take samples from both producer and experiment stations. We take it to the lab, we do analysis, we use our 3 curves to predict the in rate that would be needed for that particular site. Now, as you can see, I've put several of those up there. You can see pine tree is listed in some of these, following both soybeans and rice. And you can see up here we have the soil test value. There's a pretty nice range there from all across the state, both high and low. And then we have the units of N that would be predicted from the 3 curves. You can see that between the 90 and 95, there's about a 20 to 25 unit per acre difference. And between the 95 and 100, there's about a 30 to 35 unit difference per acre. Well, when you start talking about $1,000, $1,500 per ton of urea, this can turn into real savings when you look at the acreage that you're producing. One thing that I would like to point out here is that we have found instances where you can reduce your nitrogen fertilizer inputs, but we also have found other instances where you may actually need to increase your nitrogen fertilizer inputs. There's the potential there that you could actually increase your yields from utilizing more than 150 units of N. So this isn't a save-all in the sense that we're going to be able to cut everyone's nitrogen rate. What it allows you to do is to go back to that site-specific management and potentially maximize your yield either through the increase of your nitrogen fertilizer inputs or the decrease. One exciting thing that we do see in a lot of these fields is when you pull back on that in rate to the 90-95%, you're also going to increase a lot of other yield-reducing components, such as disease, such as lodging. And so Dr. Cartwright has mentioned looking at some interaction studies where we can actually reduce the in rate and reduce fungicide inputs at the same time while still maximizing that yield. But really the 2 things we have to solve before we can really use this on a wide production standpoint are when do we have to take the samples and what type of variability are we dealing with out there. The one thing that I haven't mentioned is the depth that you have to take the sample. In order to get an accurate representation of the nitrogen within a field, you have to take an 18-inch soil depth. That sounds like a lot, but it goes back to that cost savings, the potential that you have with your cost savings. And what we have found that is when you sample 0 to 6 inches, you might have 4 or 5 management areas within a field. But when you sample to 18 inches for the nitrogen soil test, you really lower your management zones and the field becomes very uniform because you're sampling over such a wide soil volume.